Thank you. First, I would like to thank Frank for inviting me and for creating this wonderful atmosphere that we're all enjoying and sharing thoughts and money, hopefully. Those of you who earlier today heard Lou Hawthorne talk are probably now familiar with probably one of the best members of our team. It's a little dog called Paco. And Paco greets everybody who gets into the clinic and makes sure that their life goes really very well that particular day. In the short time that we have, I will introduce you to what really sparked this idea to use therapeutic plasma exchange for rejuvenation or longevity, introduce you to what therapeutic apheresis is all about, and then share with you some of our initial studies. So you'll hear more data today, and then I'll introduce you to our new company, Lyfspn. As you heard earlier today, the seminal paper from Irina Comboy and Mike Comboy and their collaborators really sparked this whole thing. And you saw what they did. Their model, animal model, is called parabiosis. And what they did, they combined the circulation of one old and one younger mouse. And what happened is the young mouse became older and the old mouse became younger. So the problem with all that was that you're not a mouse. So we had to find a way to kind of create a parabiosis in humans. So this task was put on my shoulders, and I presented a hypothesis, which I published in 2012, of how to do that. So basically, I introduced therapeutic plasma exchange as a modality of human parabiosis. Those of you who are not familiar with therapeutic plasma exchange, I'll play a short video here that will just tell you what this is all about.
Therapeutic plasma exchange, or TPE, refers to a specialized medical procedure in which blood separation technology is used to remove abnormal plasma constituents. Whole blood is removed from the patient into a blood cell separator, which utilizes centrifugal forces to separate whole blood into its individual components: plasma, platelets, white blood cells, and red blood cells. Plasma can be removed and replaced with physiologic fluids to treat relatively uncommon but usually life-threatening diseases.
So my idea was that instead of hooking up an older individual to another younger individual, which is kind of impossible, to hook up an older individual to a machine. And the machine will do what you just saw, basically separating whole blood into cells and plasma. It was presumed, and we still believe, that plasma is what is important in this situation rather than the cells. So plasma is removed, whole blood is removed from the person and separated into plasma and cells, and then we throw the plasma away. An important question was, what do we put back? Because we're removing 2 to 3 liters of plasma at one point. So in order for a person not to die, we have to replace that. So the question was, what do we replace with? And initially, everybody wanted to replace that with plasma taken from younger individuals. The assumption was that something in the plasma was the silver bullet that people have been looking for millions of years. So fresh frozen plasma was an option, but certainly not in my opinion. In my writings in 2012, I really was very firm on saying fresh frozen plasma should not be used. And the reason for that is that I have experience with fresh frozen plasma with very sick people over the last 30 years. And what happens is if you use plasmapheresis and use as a replacement fluid fresh frozen plasma, the side effects are dramatically high. And that is very important, especially in the longevity field, where we are not dealing with very sick people. Most of the people who come for our clinical trials are relatively healthy. There isn't much wrong with them. So, in my opinion, giving them something that potentially can cause serious side effects, including death, was not an option. There are other reasons as well. We don't have the time to go into it. But if you're interested, we can talk after the sessions here. So we chose to use, instead of fresh frozen plasma, human albumin. So human albumin is the largest component of human plasma, and it is made of human plasma, but it is manipulated chemically and with heat to a point that there is no transmission of any diseases, and it's very safe. So it becomes from plasma, from a blood product, it becomes a pharmaceutical. It undergoes cone fractionation, which basically separates the different proteins of plasma into albumin and other components like coagulation factors and immunoglobulins. And the companies that make these components, they sell them separately. So the other advantages of using albumin is that albumin has proven to be a very powerful antioxidant. In fact, it's the most powerful antioxidant in the human body. It is also anti-inflammatory, and it is immunomodulatory. And as you will see, this is very important in fighting aging. So as you already heard numerous times, aging is an extremely complex process. We have not gotten to the bottom of it. We have learned a great deal over the last 25 years, and we continue to learn more and more. But at this point, there are several things that we know for sure. There are several processes that take place and lead to aging. One of them is inflammaging, chronic inflammation. And there are two processes that happen that kind of contribute to chronic inflammation. And one of them is immunosenescence, aging of the immune system. And the other one is cellular senescence. Cellular senescence, as you heard even in the last talks, produces SASP, these pro-inflammatory factors that contribute to further exacerbating chronic inflammation. So chronic inflammation and inflammaging is the key to aging. So today we know from a variety of studies that as we age, as we get older, the older we get, the more chronic inflammation develops in the body because of the aging process. And this leads to all kinds of diseases. These diseases that you see here are primarily diseases of older people. So I bet you or any of you have never seen anybody who died of old age. It doesn't exist. People die of diseases. So if we can prevent these diseases, we will expand health span as well as lifespan. These are some of our preliminary studies that we did with humans and plasma exchange. So plasma exchange in general, for a variety of diseases, it has always been thought to be removing stuff, removing proteins, removing antibodies, circulating immune complexes, LDL, a variety of different things. So we have shown since the 80s that that's not the case. Plasmapheresis does a lot of different things. And as you can see here, plasmapheresis does remove, does remove a variety of substances that are related to acute and chronic inflammation. But in addition to that, it not only removes the substances that we know that cause chronic inflammation, but they also upregulate substances that contribute to regulation of the immune system. In addition to that, something we showed in the 80s was that we can change the phenotype of immunocompetent cells using therapeutic plasma exchange. And at the time, we had 2 or 3 monoclonal antibodies, and flow cytometry that you heard about today, this morning, or earlier today, was just the beginning of this huge field. And today, we use 40 different colors so we can measure different changes in these patients. But as you can see here, we do change the phenotype of the cells as we progress. These are 1, 2, these are the number of treatments the patient underwent, and this is the beginning. And you can see here, very important immunoregulatory cells go up. This is our paper that was published earlier this year, and we did see some additional studies along the same lines and more. And I would share with you some of our data. And again, you can see here that we can affect the cells. These are the lymphoid sides of the cells. We heard from Eric this morning what they are all about, and that's about regulation of the immune system and inflammation. And here, see the myeloid cells and some cells that go up. In addition to that, we found that there is less DNA damage as we continue with the plasma exchange. And in general terms, this is the new biologic clock, as you heard a lot today about, that was developed by Irina Comboy earlier this year. So the senescent markers, in this case P16, was lowered as well. So this is something that's very interesting, and it shows that pro-inflammatory factors decrease during treatment with plasma exchange. So on the left-hand side is a control sample from older individuals, and on the right-hand side is a blood sample from younger individuals. As you can see here, these are all blue, and the red and orange dots, these are pro-inflammatory factors that are associated with aging. And as we go along, this is before the first treatment, this is the first treatment, second treatment, and so forth. During the course of 5 treatments, these factors are removed, and the proteome of this patient looks young at the end of 5 treatments. The same is true for the apoptotic process as well. So interestingly enough, we also found that certain pathways are affected as well. And these involve pathways that regulate the response to cancer cells, and certain cancers, predominantly gastric cancer here, pancreatic cancer. So this was very important and was interesting for us to see. So in conclusion, therapeutic plasma exchange appears to affect the entire body system. You know, we affect the epigenetic system. We affect inflammatory response, DNA damage, and risk of diseases. So at the end of the day, there is a new environment that we create that allows the tissues in the body to function properly. And this is how it's done. So here you have plasma exchange, which removes inflammatory factors. It also removes SASP, which is the production of cellular senescent cells, and changes positively the immunocompetent cells phenotype. So the old milieu that is created from the aging process is changed to a healthy milieu. So our initial experiments over the last several years demonstrated that we can remove pro-inflammatory factors. We improve the balance of immunomodulatory cells. We provide a very potent antioxidant effect. And clinically, there is improvement of joint stiffness and pain, liver function, renal function, and it prevents infections. We are very proud that none of our participants over the last several years has developed any infection, and they went through the COVID pandemic without any serious problems. And these are older people, the ones that were more vulnerable to the infection from COVID. Anyway, so we did all that. However, we did it without controls and small numbers. So now we have embarked into the golden state of the science, and that is a controlled clinical trial with placebo that will hopefully prove what we already have shown in uncontrolled trials. I'm a co-founder of a company called Lyfspn. When we created this company to study aging, especially therapeutic plasma exchange in aging, we're collaborating with the Buck Institute from Nevada, and we're very hopeful that what we're doing right now is going to demonstrate that therapeutic plasma exchange in the most scientific way possible will prove to be a helpful approach to longevity and rejuvenation. In this study, we have 4 different groups. People are randomly assigned to one of these groups. A participant has 25% chance to be in the placebo group. Having said that, if we do find that one of these treatments is helpful, then the people in the placebo group are offered for free the entire course of the treatment. So all the treatments and lab tests are also free, except for the insurance coverage of regular chemistry and CBC and tests that are covered by insurance. At the bottom is some information if you're interested to refer some of your clients or patients. Let us know. And it's a good way to get in touch with us as well. In the placebo group, we see that the patient is in a separate room. There is a screen that separates the patient from the machines and the nurses. So they don't see what's happening, and the lines, which supposedly have blood, are covered, so they don't see that either. It is very well accepted so far by everybody who has participated, and we are very hopeful that we can complete the study and have positive results. I know that I'm done a little early, but that's okay. You can ask questions. I will leave you with this.
So actually, the first question is coming from me. This sounds too good to be true. So are there any downsides you're aware of?
Well, it's something that we've been doing for a long time, and we believe that this is the future of longevity. I think that there is no other clinical trial in humans that has gotten that far. So I think that based on that, we will continue to look into the basics. We are using new laboratory tests with the help of the Buck Institute and all their experimental and dramatic tests and biologic clocks and so forth. So we hope that this will add to what we have already demonstrated. But again, I think we're far ahead of the game than anybody else, and we are open and we're looking for improving the process. This, as you can see, this has a lot of technology in it, so there is room for improving the technology. Hopefully, as you heard today, we will identify certain factors that we can specifically remove. Before we get to the nanotherapy as a treatment of choice, there are columns that we can use, there are other technology. Basically, what we're using here in the not here, but in the United States, is about 25 years behind what Europe and Japan are. We're using machines that were developed 50 years ago. So there is room for developing the technology, and there is, of course, room to developing additives. Maybe we can improve on the albumin and add something else to the replacement fluids. So we have a long way ahead of us, but so far the results are encouraging.
Wonderful. Now let's open it to the audience. There's someone.
Thank you so much for your talk. So once the patient undergoes the therapy, you can assume that in some period of time the parameters should return back, right? It can be like, months or years or tens of years. So have you tried to estimate what's the length of time it will take for the parameters to return back?
Well, this is a very relevant question, and one that I get all the time. We don't have an answer to that. My suspicion is that everybody is different. So you will be different than anybody else. However, we have studied patients who have undergone monthly procedures. And it appears that for about a month, the results are sustained. Right now, we're studying different periods, so I don't have the answer yet, but hopefully by the end of next year, we will know. I think that at the moment, if I have to guess, it will be between 2 and 3 months.
Okay, final question over here.
Here, what's the best parameter to monitor the treatment?
I didn't hear that.
What is the best parameter to monitor the treatment success?
The biomarkers that we're using today are fairly extensive, and they're becoming more and more extensive as we combine what we have done so far with the Buck Institute. So here what I showed you, these are proteomes that are measuring about 5,000 different proteins. So we measure that and we're learning. I'm not here to say that exactly what we know, that one or the other is more beneficial, but we follow that. We also follow people clinically. And some of the reports are very interesting. At the clinical trial that we're doing now, we're measuring a variety of clinical parameters, including cognition, strength, and so forth. So there are different ways to measure the response. I'm not sure I know exactly the answer, but we are working on the bioparameters as well as clinical parameters. Hopefully by next year we'll have the answers.
Thank you. One more? Okay, one more. Who wanted it? Could you pass it along? Yeah, thank you.
So this is FDA-approved apheresis and albumin. What is your strategy as a company to have some proprietary advantage around this treatment?
Excellent question. I think that this is very important, and we will be working mainly with insurance companies because, as you said, it's FDA-approved procedure. I, as a physician, can use it for anything I want. However, it's very expensive, and we have to convince the insurance companies that it is time that they invest in preventive medicine, because this is what it is. If we can prevent all these diseases that I showed you, we're going to save enormous amounts of money. But it takes thinking, it takes convincing, this is why we're doing placebo-controlled clinical trials, so we have more power, if you will, to convince the insurance companies how to do that.
Even if that, hopefully that happens for humanity, but even if that happens as a company, how would you prevent anybody else from doing something similar?
I'm not company person, so I'm a physician. What I want is to prevent and do well with everybody who is here, everybody in the world. I don't care about the money.
Yeah, it was a good answer. Thank you.
Great answer.
Thank
Lovely
you.
having you.
Thanks.
Thank you.